I remember that.
Oh, yeah.
Well, she's a perfect human being. So
Yeah. All right, we have it all folded. We're getting our circles on it. Now, question. Question. If I was to ask you right now with a circle on your patty paper to just make this, go. How precise would we be?
Not
Not so much.
No, honestly.
And would we totally understand all the numbers that we were writing? Maybe, maybe not.
The blue one.
But if we were to work on it piece by piece,
We can dive in.
Maybe.
Maybe
we can get it done.
This ain't bad.
Okay? Now hold on. How are we going to do it piece by piece? Well, we're going to start with a single quadrant. You ready? Okay, ready? Hold on. All right. You ready? You have your circle. It should look like this, true? You have a circle and you have a center, yeah?
Yeah.
Okay. Now, here's what I want you to do. That's not going to work so good. Close enough. Okay. I want you to go ahead and fold it into a 90-degree angle. Yep. Get it back to the little square. Get it back to the little square. Now hold on. When you get it back to a square, here's what I need you to do. Ready? When you fold it and fold it, okay, I need you to be holding the center and not another corner. Are you holding the center and not another corner?
Yes.
Okay, you should see your circle. Right? Okay.
Yes.
Are you staring at 90 degrees?
Yes.
Perfect. Unfold it and draw your quadrants. True? Draw your quadrants. Draw your x-axis and your y-axis. Sketch it with your straight edge, if you have not yet already. Don't worry, we'll come back. When you sketch those lines, aren't you cutting your entire circle into 4 pieces? And when you cut it into 4 pieces, couldn't I label this one as 0 and 2 pi? Couldn't I label this one as pi? Remember, calzone. How much a pi would this one be? How much pi, how much calzone would this one be? Just this one. 90 degrees. How much? 1 half pi, right? So if we were to count by those little 90s, by those little quadrants, don't I have 1 half pi? 1 whole pi. What would this one be? 3 pi over 2, or 1 1/2 pi, right? So I want you to go ahead and label your angles. So we start at 0. 0, 1 half pi, 2 halves pi, 3 halves pi, 4 halves pi. But why don't I write 2 halves pi? 2 over 2 is just 1 pi. 3 halves pi, 4 halves pi. Why don't I write 4 halves pi? 4 over 2? 2 pi. So it's easier to write the reduced form, right? Okay, go ahead and fold back into your 90 and get your first quadrant again. You're holding the center. So we trace with our straight edge. Hold on, we're making sure that we know these angles because they get confusing in the future for most of you. So you traced your axes and then you labeled, right? 0, 1 half, 2 halves, 3 halves, 4 halves, but we reduced the 2 halves to be 1, and we reduced the 4 halves to be 2. Now we fold it back in. There are more special angles than the 90 degree, which is pi over 2. What's the next easiest one that we could fold and get precisely? 45. Fold it in half, right? You're holding your center. Fold in half. As carefully as possible, fold in half. And when you fold one quadrant in half, remember, you're holding the center. You should still have the center. There should be a little like, there's a taco, right? Okay. Fold it in half and then unfold. Don't you have new lines all of a sudden, kiddos? And what are those new lines symbolizing? 45 degrees. But how much of pi, hold on, just unfold it to be, you guys unfold it to be your calzone? Just unfold it to be your calzone. Have it be a half circle, okay? If pi is that half circle, right, 180 degrees, if pi is that half circle, question, what did you just cut pi into? Fourths, right? Right? If you just look at the top half. We just cut pi into how many pieces? 1, 2, 3, and 4. So what are we going to label those pieces as? 1/4 pi, or pi over 4? 2/4. Oh, that's, wait, ready? 1/4 plus 1/4 is 1/2. No big deal. He's already labeled. 3/4. Oh, there he is. 4/4. Oh, he's the entire thing. We already have him labeled, right? So we have 1/4. Do you guys trace your lines? We have 1/4 pi over 4. 2/4 already labeled. 3/4, there he is. 4/4 already labeled. That's the whole pi. So how are we going to keep on counting down, my ones that have been afraid of these angles in the past? If that's 4/4, what's next? 1/4, 2/4, 3/4, 4/4, 5/4. What's next? 6/4. But wait a minute, why don't I write 6/4? It's 3 over 2. So what's next? 7/4. 7 pi over 4. What's next? 8/4, which is 2 pi. Done. We're just counting by fractions. That's all the unit circle is as far as the radians. 1/4, 2/4, already there. 3/4, 4/4, already there and reduced. 5/4, 6/4, already there and reduced. 7/4, 8/4, already there and reduced. Does that make sense? So the fourths are all the pi over 4s, the fourths, the 1/4, 3/4, 5/4, 7/4 are all the 45-degree angles in the different quadrants, and they're odd because they don't reduce. You got it?
Yes, ma'am.
Okay. Go back to your 90. Center. You're pinching the center. Go back to your first quadrant again. Because he's been cut in half. That's great. Now we got to cut him into thirds. Okay. Wait, this is the hard one. So everybody try to get here. Keep him on 90. Keep him on 90. Keep him on 90. Keep him on 90. Okay, now hold on. I'm going to show you what I want you to do, and let's see if you can actually do it. It's a little rough. Nicole, Sean, Eric, focus. Okay. Right now, you have a 90. And technically, you're focused solely on this little region right here, right?
Yeah.
If we need to split into thirds, we need an angle a little bit after pi over 4. And we need an angle a little bit before, about the same amount, before pi over 4. Now here's the struggle. How do we make that fold? Has anybody ever had a bugle? Not the instrument, but the little chip that's round and the little one.
Yeah.
Or has anybody ever made a burrito? Yes. Do you just fold it together like a taco?
No.
You go in and back.
Then you roll.
45 was the taco. We just folded. No big deal. Right? The 30s, or the thirds, we got to make a burrito. Ready? My finger. Watch. Don't fold. Watch. Especially boys. Watch. Yeah, right at the center, right? Hold in the center. Ready? I'm going to fold so that there's a little bit before the 45. Don't fold again. I'm going to curl like a burrito over. We do like a popcornopolis, like one of those little like stuff inside. Okay, I don't know. Support fundraiser. You want to make sure the 45 is in the middle of the little cone that you just made, right? And then you slightly, trying to keep everything even, start to crease it. And when you're done, you should have, if you can keep that little fold in the middle, approximately. If I fold with my 45 in the middle, I'm going to have my thirds, a 1 and a 2 and a 3. So here's your 45. I'm folding in, and they should overlap. So tuck them around each other like a burrito. You're rolling it. And then you're rolling it. Oh, don't cut it in half, though. Don't cut it in half. That's going to be like something else. Half 45 is 22 and something. You only want 3 pieces when you're done.
Wait, I'm not reviving?
She said, like, this?
Yeah, right?
There's 2 of them.
Honestly,
That's okay.
I'm really full, so I just wait.
So I'll speak up. I'll push it.
Make it work. There you go.
Hey,
Push it.
there he is. There's my son.
It's weird when books are so nice.
I hate it.
I like it. It's freaking nice. I don't know what
Wait,
Yeah.
like this?
Then trace the lines.
Ready for one more time? Yeah. Next year, I'm going to defense bad as
I'm so proud. Thank you.
Then we'll transition to that all the time. You got to utilize it. My way or the highway.
I like it, Eric. I like it.
Slow, steady, back to race.
Push. All right, we got him?
Nope.
No. All right, hold on. Getting my lines. Now, I know it's a little tricky because yours aren't nice and colored like mine, but hold on. Look at my nice green ones. I'm getting my little folds up. There's one. Well, my pretend folds. You should probably be a little bit closer.
Right? That was wrong.
I know.
I don't know if you listen to this. I just
Okay, ready? Look at the half circle. Question, what do the green ones cut pi into? 1, 2, 3, 4, 5, 6. Right? So every little green marker, in yours, every of the ones before and after the 45.
I don't deal well with foldies. Is that all the thirds?
Because then I have 1/6 in question. Ready? Ready? What's 1/6 plus 1/6? 2/6.
So that's
Which reduces to be 1/3. So the thirds are always going to be 2/6 or the higher angle, and the 6s are always going to be a smaller piece or the smaller angle, right? 1/6 of a calzone, he's a little one. 1/3 of a calzone, he's the bigger one, right?
Yes, ma'am.
Now I have 1/6. Now this one is 1/6. We can count 2 different ways. We can say 1/3, 2/3, 3/3. That doesn't really help us with the 6s. We can do, right? We can do 1/3, 2/3, 3/3, right? So that's the pi over 3, 2 pi over 3, and the 3 pi over 3, we already have him. That's 1. So if we count by 6s, 1/6, 2/6, 3/6, that's 1/2. 4/6, that's 2/3. Who's this one? You see it? You If you can think in sixes, you'll be good. Because that's 5 pi over 6. Where's 6 pi over 6?
1.
1 pi. What's 7 pi over? Oh, he's the next one. 7 pi over 6. What's 8 pi over 6? Wait, 8 over 6 reduces to be?
4/3.
Or you can think 1/3, 2/3, 3/3, 4/3. But 8 over 6 reduces to be the same thing. 8 pi over 6, 9 pi over 6, or 4/3, 5/3. 8 pi over 6, 9 pi over 6. Sorry, that was 3 pi over 2. 10 pi over 6, that's the 5 pi over 3. Who's this guy? 12 pi over 6 is 2 pi done. Woo! All the angles in the unit circle reduced to counting by sixths, fourths, and thirds.
Beautiful.
And halves, I guess you could say. Now, hold on. What goes in the unit circle? Angles, done. But, ooh, those points, right?
Triangles.
Weren't we talking about right, no, not right triangles. Yes, true. But weren't we talking about x's and y's? So maybe some x's and y's should go in here too. Go ahead and hold on to your unit circle. Figure out your notes too, because we need to write a little bit about this. Now hold on. So far, we have our unit circle. Ta-da! Done. But hopefully you saw he really is, or can be, condensed down to counting by fractional pieces of pi. Right? All added up around, all the way to 2 pi. Now, with that, I don't know why I have that side, but that's fine. Okay. Oh, stink. What if they ask us to evaluate the 6 trigonometric functions at each real number? Well, the angles aren't enough. They put us in a place of the unit circle, but what else do we need to give the answers? We need the points. So let's come back to our unit circle. You guys still have it, right? Okay. We need points. Now, if you remember, there are basically, five different key points in the unit circle. There are 5 different key points in the unit circle. All of them come back to special triangles. And we'll look at different ways of looking at the unit circle. Some of your brains are going to like different ways better, etc., etc. But here are the 5 different main ratios in the unit circle. Ready? 0, 1/2, root 2 over 2, root 3 over 2, and 1. Okay? Those are the main ones. Those are the only ones. Sometimes they're positive, sometimes they're negative. Sometimes they're x's, sometimes they're y's. Let's see if we can figure out exactly how these work spatially. Now, some of you, this isn't going to be the way that you're going to end up memorizing it and having it solid. We're just introducing one way today, okay? But when we're trying to, okay, thank you. I got my overhead then. But I already stole someone else's overhead. All right. With all of this, why did I write them in this order? Any particular reason?
Because they're points that go.
30, 45,
They're
and 60.
points
They
that
actually
go
have
around
nothing
the
to do with the angles. I mean, it's going to apply, but it has nothing to do with the angles. Sean, what were you saying? Sequential. Really quickly, calculators out. We know what 0 is. We know what 1/2 is, right? 0.5. Question, what's root 2 over 2, real quick? This one's
That's
0.
0.7.
Get it for me.
0.7.
0.70, ... Oh, he's a little bit bigger. What's root 3 over 2?
It's 0.9 almost. It's 0.8.
Look at this guy go. 1.6. And then we have 1. I went from smallest to biggest. What's another way of thinking about that? This is 0, obviously. This is a 1 over 2, or a root 1 over 2. Root 1 is 1. Root 2 over 2 must be higher. Root 3 over 2 must be higher, and 1 will be the highest. Because that one only goes to 0.866, etc. So question. If those are our only options for x's and y's in the unit circle, first of all, at this point right here, is there a way for the x to get any further than where it is right now? So what's the x-coordinate going to be? The highest one, which is 1. Can the y-coordinate get any lower than 0? Just think of a point. And it's a unit circle with a radius of 1, so this is going to be 1, 0. Now, hold on. As we go to the next point, question. What just got smaller and what just got bigger?
The x-axis got smaller.
The x got smaller and the y got bigger. Okay, so hold on. The x got 1 smaller. What's 1 smaller than 1? I apologize. What's 1 down in the values from 1? We're going backwards.
3 over 2.
Guess what? The x gets a little bit smaller on this one. Guess what? The x gets a little bit smaller on this one. And guess where the x is on this one? Well, isn't he just 0 now? So as we go, the x is getting smaller, smaller, smaller. Oh, now he's 0. So you count backwards. The 1, the root 3 over 2, the root 2 over 2, the root 1 over 2, which is 1/2, and then the 0. But as x is decreasing, as x is working its way backwards, y is increasing. So it's 0, but what is it next? Go up through the list. 1/2. What's the next one? Square root of 2 over 2. What's the next one? And what's the last one? So basically, if you can just have those 5 numbers memorized, and you can just figure out the placement of any angle in the unit circle, you can just ask yourself the question, okay, is the x or y, whichever you're looking at, is it 0, is it 1, or is it one of the in-betweens? If it's one of the in-betweens, is it a smaller, a bigger, or a biggest? As you're gauging between the 1/2, the root 2 over 2, the root 3 over 2. So in this one, you go over a lot, up a little. That's the root 3 over 2, 1/2. Over a lot, a big x and a little y. 45s. Over the same, up the same. Over middle, up middle. That's root 2 over 2, root 2 over 2. The pi over 3s. Over a little, up a lot. Over a little, 1/2. Up a lot, root 3 over 2. And then suddenly you're going over none and up 1. Okay, well, over none, that x is 0. Up 1. Now guys, from the first quadrant, you should be able to basically go to all the other quadrants, because now what we did for pi over 3 is going to mimic what we're doing for 2 pi over 3. Because whatever we went over and up, we're just going backwards and up. And backwards, that's a negative x and a positive 1. So we're going to go negative a little, negative 1/2, and up a lot, root 3 over 2. Do you see how they mimic? Except now the x's are negative because you're going to the left. So the point, yeah, the x has to be negative. It's to the left of the y-axis. For 3 pi over 4, match it up. He's going to be the other one. But instead of going positive root 2 over 2, up root 2 over 2, you're going backwards root 2 over 2. Negative root 2 over 2. You're going up, middle, and then, back, middle, up, middle. So your x is going to be negative root 2 over 2. Your y is going to be positive root 2 over 2. For 5 pi over 6, I'm going over a lot. Not the most, but a lot. Negative root 3 over 2. And up a little. The y is 1/2. And last but not least, you're at another point on the axis, which will be over the most, negative 1, up none. Y is 0. Once again, there are different ways of memorizing this. I will show you as many as I can as I know. George Corey has something, he has like a finger trick of looking at it. There's one where you write a table and you can write it on really quickly. I can do it. I think you guys will time me at some point, maybe in definitely less than a minute, maybe less than 30 seconds. I can have all the different trig ratios that you'll ever need for a unit circle, and you could write it at the beginning of any test, any quiz, any homework, and just use the table and never have to think about this at all. But my visual ones will go faster if you can just think about where the angle, oh hey, what am I doing? Am I going over a lot, over a little, over in the middle? Going up a lot, up in the middle, up in the middle. When we come over to 7 pi over 6, we could just match them and memorize that, or we could say we're going over, we're going left or negative a lot and down a little. Negative a lot would be negative root 3 over 2. Down a little would be negative 1/2. The x is negative because we're going left, and the y is negative because we're going down. As we get to 5 pi over 4, we're going over, we're going left, the middle amount.
The cup again?
The cup again? Yeah. What left middle, which is negative root 2 over 2. And I'm going down middle, which is negative root 2 over 2. For 4 pi over 3, I'm going left a little, down a lot. So negative 1 half, negative root 3 over 2. For 3 pi over 2, ooh, I'm on the axis again. So down the most, well, over none, right? 0. And then down the most, 0, negative 1. 5 pi over 3, I'm going right a little, down a lot. Right a little is going to be a positive x. Down a lot is going to be a negative y. 7 pi over 4. Right the middle, down the middle, which will be positive root 2 over 2. So I'm going to the right, negative root 2 over 2 for the y. Over a lot, down a little. Over a lot to the right, positive, down a little, negative 1 half, and I'm back at the beginning. Dun, 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 dun. Pass around the tape. If I were you in your notes somewhere, find a place to tape them in. That way you won't have to keep manhandling him and then have him break. If you want to find a place to put them in your notes, there's a little piece of tape. You can either burrito it on the back, or you can put it in, or you can wait and staple it. But just to reinforce the idea that the unit circle really just works by fractions. Okay, so with this, kiddos, you have the unit circle in front of you. How could we do these problems? Now, technically, can you just look at your unit circle? Yes. However, can you just look at your unit circle on the quiz or a test? No, never, ever, 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 ever. I still tell my calculus kids, you were supposed to learn your unit circle last year. We have to get it memorized. Otherwise, it'll turn into a weakness, a big one. Pi over 6. Think of calzone, the top half of the circle, right? 1/6. How big is the piece? The littlest one. True? Okay. What's his point at pi over 6? Over a lot? Root 3 over 2? Up a little. 1 half. Maybe that makes sense. Maybe we'll have to memorize it another way. You could look at your unit circle as well. A question, kiddos. You wrote in your notes yesterday, what does the x and what does the y stand for again? Help me out. Who's the x?
This is sine of theta. Cosine.
The x is the adjacent angle, or the adjacent side. That's going to be cosine. And the y is going to be sine. Now I'm just doing letter A right now. Whoop. Just modeling for you, and it says find all 6 trig functions. All 6? No way, that's mean. Hold on. What can we fill in right away if we start with sine? All right, sine of theta, but sine of who? Sine of pi over 6. Okay. I should write equals. Goodness gracious. Math teachers these days. Okay, so sine of pi over 6. Who is he? Who's the opposite? Up a little, so 1 half. Cosine of pi over 6. He's the other one. Adjacent over a lot. Root 3 over 2. Oh no, how am I going to figure out tangent of pi over 6? Technically you have those little formulas. Who is tangent? Opposite over adjacent, or sine over cosine, or y over x. That's what you wrote down in your notes. How would you do 1 half over root 3 over 2? Multiply by the reciprocal. Yeah, we could do that. So we could do 1 half times 2 over rad 3. That's one way. For those of you that like my trick, you could just multiply top and bottom by 2. Right? Multiply by those little denominators that were stuck. You get the same answer of 1 over rad 3. Is that proper? It's right. But wouldn't you rationalize it? Multiply top and bottom by rad 3 over 3? Okay. So we have sine. We have cosine. We have tangent. How do we find the other 3? We flip them because the next one would be cosecant. And cosecant says, hey, take the sine and flip them. Flip them, yeah. Find the reciprocal. Cosecant is 1 over sine. We'll memorize some more formulas with that. But right now we're just trying to use the formulas. Cosecant is 1 over y, or 1 over sine. So if I flip 1/2, what do I get? Oh, sweet, that's awesome. Didn't have to think about it. For secant, we flip the next one, cosine. Secant, 1/cosine. You can think of it, there's only one co. There's only one co. Cosecant must be with sine. Secant must be with cosine. Easy co. Silly way of remembering. You flip it. 2/rad3. One question. Is that proper? It's right. It's not proper. You'd have to multiply top and bottom by the square root, right? So multiply top by √3, that'd be 2√3. Multiply the bottom by √3, the root disappears. Right? If you multiply top and bottom to rationalize. So cosecant, you flip sine. Secant, you flip cosine. What's the last one going to be? Cotangent. You flip tangent. Ew, gross. Wait, wasn't that tangent also? Weren't they the same? Let's flip him. √3. What would happen if you had flipped the other one? You would have gotten 3/rad3. You would have had to rationalize. I'll actually show it this time. You would have gotten 3/rad3 all over 3, which would end up being, it's a little easier if you flip that one instead. But either way, it works. Okay, what did I just do? Took an angle, figured out his placement, looked at his x and his y, and used it to find all 6 of my trig functions. Now, how on earth did I do that? Well, I knew lots of stuff and formulas in my head, but technically, what could you use to help you do that? Don't you have little formulas for how to get all 6? This is just the beginning of trig. We have things like secant is 1/cosine that we have to memorize and work with, etc., etc. But technically, you can just use this for this type of problem for right now as we're building up. Okay, now we could have done more angles, right? But the first step is find the placement in the unit circle and use the points. Now, question. Oh, what do I have? These are mostly homework helps. Mostly homework helps? Yeah. This is our last little bit. So let's get this down. Okay, we have 2 minutes. We can do this. The rest are homework helps. Really quickly, sine and cosine. We just saw sine of any angle has to be in between 1 and -1. Sine can never be any bigger, because it's held within the circle and it can't get any bigger than 1, or it can't go any more negative than -1. And cosine is the same. So if you ever see a sine or cosine that's bigger than that, it's illegal. You're going to, oops, not do that. That would be an illegal. And both of them completely repeat every 2 pi. So as soon as you go around 2 pi, if you were to go 2 pi plus 1 pi over 6, you would be at the exact same place as regular pi over 6. It would have the exact same sign. So cosine and sine both repeat every 2 pi. That's called their period. We'll talk more about that sort of stuff. Period, frequency, blah, blah, blah later. Trig ratios are the same at coterminal angles. So therefore, I'll give you an example. Sine of pi over 6 is equal to sine of 13 pi over 6.
That's period again.
How long it takes to complete, to start repeating.
Okay.
To start repeating the same. And then there are a few properties, even and odd properties, of sine and cosine and all the rest down below. Now kiddos, here's Dylan. I think you have enough to do homework. Tomorrow what we're going to do is I'll put the screen up at the very beginning, hopefully before the bell rings. You update your notes with whatever you didn't write down. You can do it tonight. Do as much of your homework as you can. We probably won't grade it tomorrow, but I give you a warning. We're only going to spend about 10 more minutes doing examples, like just using the unit circle. Then we're going to section 4.3. Sound good? Sounds good. So start homework. We won't grade it until later. Tape is somewhere. There you go.
Yeah.
Bye guys, we'll see you later. You can get tape tomorrow too. Just don't lose your little tiny paper. Put it in your little pocket. Bye guys. Oh, thank you.